Hi, thanks for tuning in again today. Welcome back to the channel. I've got a 447 here. Doesn't look like much now. I have a video on it from quite a while ago when I dismantled it and measured all the components. Well, today this engine is going to be reassembled. And then this antique little engine is going to go back out and fly again. So that's awesome. So stay tuned and we'll go through the process. As you can see, I have the crankcase halves all cleaned up nicely. Part of the prep is I've checked all the thread holes to make sure that everything is going to screw in easily so that it torques properly. And I just already made a mark here and with marker here, and it coincides with the oil hole that feeds the bearings from the crankcase. So why did I put a mark on there? Let me show you in more detail on the mag end here, and I'll show you why I do that. So this is the mag end of this engine, and this is the oil hole that corresponds to the mag end bearing that fits in here, so that the oil gas mix can circulate from this side of the bearing or from this hole and travel back and forth, etc. Lubricate the bearing. You get the idea. So what I want to do now is I'm going to index the seal, and what I mean by indexing is I'm going to make a mark right here with my marker that corresponds to the center of the oil hole. Now what I want to do now on the seal is I want to do the same type of an idea, and actually I'm going to show you what the problem is first before I show you how I do this. And what we can see on the seal here is it has these little feet that hold it off of the bearing, and then there's a little lower space in between here. We can see that. Yeah. Okay. So now I'm just going to put this in place where it would be if it was on the crankshaft. So it has this little protrusion down the center of the seal here that fits in this groove here. So I'm just going to put it in here as it would be if I just wasn't concerned with it at all and just assembled it without indexing the seal. Now, so there's the oil hole, and here's a foot, and the little foot here, or standoff, whatever you want to call it, is covering the hole. So, so look how much that this foot, because this seal is in the position it would be in when the engine's assembled, how much of that hole is restricting. It's almost half. So that's, no, we definitely don't want that to happen. So let me pull the seal out and go back here again. And what I'll do is I'll find a spot in between the feet right here. I put a little mark on the back here, and then I'll mark it that way, so that if you ever see an engine that I put together, it's going to have a mark on it. You're going to say, why does it have a mark? Well, this is why. So now, when the engine goes together, where the crankshaft is dropped in, then I'm going to line this up with that mark, and I'm looking at it from this end to line my marks up perfectly. And what is the result? Let's zoom in here again and see. Look, it's just at the edge of the hole. So that whole oil hole is nicely open now. So I don't know, you might find that quite amazing, but it's just one of those little things that you can do when you put the engine together to ensure that it's going to live, because that's what we want to do. So it's a simple indexing of the crankshaft seals. So both of my seals are marked with my index on it. The crankcase over there is marked as well. And then you'll see that this probably looks like, you know, white grease. It's not white grease. It's actually very expensive rolling bearing grease, they call it. And this is the PTO one. It's pretty much full and level. And I usually put a fair amount in the mag end as well. So this is what it is. This is that stuff. Now I say it looks like white grease, but it's not. It's extremely expensive. It is the correct lube to put in there. So anyway, if you're happy, and if you're doing this, this is what you really should be using. I've also, of course, replaced all the rubber O-rings on the bearings, and the crank is set right into position now. So now's the time to check and see, make sure that my lines are lined up. And as we can see, or maybe not see, but there we go. Okay, there's my black mark and my indexing mark on the seal, and the same on this end, probably a little easier to see. So there we go, right there. So I know that the oil hole is not obstructed by anything. That's what this seal indexing is all about. Oil flow is good. Restricted oil flow, not so good. So I've got another video out there on sealing the crankcase. And as I said before, this is a timed event, and I need to have everything ready to go. And I'm just looking at, no, I don't. Okay. So I have to stop this process here. And I'm going to, yeah. So not a big deal. If you, get everything out. I see what I've missed right now as the tool goes. So take this sealer off and wash this half of the crankcase. And then double check, like I didn't, and make sure that you have all of your necessities out for when you do this project. Like I said, timed event, I'm not happy if I have to wait. I need to have everything out and ready to go. And I definitely messed that one up. So I'll take this over and wash it again. And because there's some, yep. All right. Oh, well, what can you do? That's the reality of doing this stuff. Sometimes I get to do it twice, but I'd rather do it now again to clean it and reseal it than have it leak after. It's not worth it. So stop now, spend a few minutes extra now. Don't have to spend a whole bunch of time later. Okay, here I am back again. This is what I noticed was not there. I use this to install the ignition plate so that I can line up the block easier. So that's what I saw was missing. And of course, I got rid of some of the other things. There was a little bit of clutter there, and that was not good. So we need to have this area organized, which is how I started doing this, and without that. Okay, so back we go. So dish out a little bit of sealer on here, and that was just good practice. So we'll get a nice even coat on here, and as I said, you can go and check out the other video. We don't need to put a whole tube on here. We just need enough. This is almost a perfect fit on the two halves when they go together. So it really doesn't need a whole lot to seal it in reality. So we don't need to put half a tube on there. That's sort of my point. What we need to do now is check the end of the case to see if it's a straight line. Okay, so let me move in, and this is important, so I wanted to show you this part. Hopefully it doesn't take too long. Okay, so I have a machinist square here and a light. So I'm going to put it on there, and then I'm going to look through here, and I'm trying to find out if I see light through here. So in other words, does it look like that? Because that would mean that the case halves are not lined up. So if there's a gearbox going on here, which there is, you need to make sure that this is all going together straight And that looks perfect. Okay. Part of the reason they're using the ignition on it, the ignition plate on it, it helps an awful lot. In order to do this, and again, not sure if this is showing or not, but whoops. Okay. 1, 2, number 3. Final check on here. Wherever it is right now, I mean, I can't correct it now. If it's out, I'd have to take it apart. So anyway, that's perfect. So that part is done. So now we're all happy with that. Let's take our alignment plate or stator plate off, and I'll store that away for next time. Now, I mean, you could, of course, you could use your plate with the stator on it. That's not a problem either. You don't have to take it apart to do this. So use a complete plate if you want. It's just handy to have this one. So I'm going to install the all those little rollers that are sometimes kind of difficult for some people to get in. So what I did was just put a little lick there, as you can see, of white lithium grease there. And I have right here just below, I have all of my, oh, here we go. No, you can't see it anyway. There we go. So I have all of my rollers down here. They're all washed, and so I just count them off, 2 and 4 and 31. Okay, so there they all are, nice and neat and tidy in there. Then there's a fair amount of grease came through the backside, so that's going to hold the ring on. So I'll just give it another little rub of grease on this side, and that'll hold this ring in, or right there. And there we go. So now I can handle this all I want. Nothing is going to go anywhere. So now I'm going to get the piston ready to go. I've already pre-oiled the piston pin holes, and I'll pre-oil the pin. Then we have to see which the piston's marked, of course, with exhaust side. I don't know if you can see it on there, but right there, it's marked on there. So this faces the exhaust side. And why is that important? Well, we might notice the ring gaps are always on the opposite side. The ring gaps are always on the intake side. So if you ever, whoops, kick the camera again. So the intake side is this way. So I'm going to put the pin in. It's a nice fit. All these parts are just at room temperature. Well, of course, room temperature today, it's like, I think it's like 80 in here today. It's fairly warm. So slide that up. We'll get it lined up. You probably won't be able to see most of this, but I'm just going to push the pin through, and that'll push the little brass slug right out the other side. There we go. There. Perfect. All right, that's it for today. So the next extremely important item in the assembly is to install the piston pin lock rings, circlips, whatever you'd like to call them. These, of course, are brand new. We never, ever reuse these because they will not hold properly. So if you don't have these, then you need to get them, the correct ones. Because when you go, oh no, they look okay, it'll probably be okay. No, it won't be. These are a disposable item. Put it in once. If I'm assembling this and say I put the piston on backwards, and then my final check, I go, oh, nope, I have to take this off. It's brand new. It's been in the groove. I throw it away. Okay, so it doesn't matter if it's been in there for 2 minutes or it's been in there for 200 hours. If it comes out, these go in the garbage. So these are brand new. Now, with that out of the way, now this tool, I'm sure you could put them in somehow without the tool, but I don't do that. I use the correct tool. So we'll load the ring, the circlip, I should say, into the tool. Then we push it down, and this tool is tapered inside, and it goes in, loads into a snap groove in the other end. So we see the diameter here, and of course the diameter is smaller at this end. So that's the taper that's in it. And there it is, loaded right in, ready to install. So I want to put the gap, which is down here, and I used the little window here. This is a tool I modified, and figure out where the top is going to be. So this point right here is going to be the top. So now we'll get ready to do the install. Piston that's going to receive it all the way at top dead center, all the way up, whichever way you would like to describe that. Now remember where are we here? Here's the opening in the ring, and I want that to be here at the bottom. It's very important. And this was my top location from upper location. So what I'm going to do is I'm going to slide it in, and then I want to support the piston from the opposite side, and I want it to go this way as far as possible. So I'm having a look at that to make sure that my upper point is at the top as close as I can get it. And then I come in with this, just a small hammer, but you don't want to be tappy on this thing. It doesn't work that way. You just give it a nice, good wrap with a follow through. Okay. So there we go. One installed. So there we can see the circlip in there, and we can see the opening is right at the bottom. So that's exactly what we want. Now in part 4 of this video series on this engine, remember we had the 4 holes in here. There's a piece missing in between. These two guys, this gasket was 20 thousandths thick, so we can measure that and see that it's 20 thousandths thick. Then we want to ensure that the new gaskets are also the same, 20 thousandths on that one. And I'm sure this is the same, but we're going to check it anyway. And 20 thousandths on that one. So these are critical, the thickness of the base gasket. You might just think, well, it's just a gasket. Well, it is, but the thickness of the gasket, it can affect the compression ratio and the port timing, the characteristics of how the engine actually runs. And if it's too thin, it can increase the compression ratio enough that it can have some detonation problems, which in other words is short engine life. So critical importance, the thickness of these gaskets. I have no idea how this is going to turn out, whether it's going to be just all of my hands in the way or not. So I have my holder in here from the 503, and I'm compressing the rings just with my fingers from the side. I have the pins lined up on the end of the piston rings, and there we go. Done. It's on. Now I just want to confirm that we have the correct thickness head gasket. So here is an original head gasket. I'm going to check the thickness of a spot where it was never compressed. It's 40 thousandths thick. And our replacement gaskets are, that one is 40 thousandths, and this is 40 thousandths of an inch. So perfect. Just wanted to go over that and confirm that it was correct, because just as with the base gasket, it needs to be the right thickness because we'll change the compression ratio and the port timing. With the head gasket being too thin, we would change the compression ratio. A combination of too thin of a base gasket and too thin of a head gasket combined is going to be an issue, because it's going to have too much compression ratio, and then we can get into pre-ignition detonation, which ultimately results in engine failures. So critically important that these components are all the original thickness as the engine was designed. So I've now got the cylinder head gaskets are set in place. What I need to do next is I need to align the cylinders, and I need something flat to go across. So on these singles where I don't actually have a plate, I'm going to use the intake manifold, but these things are very rarely ever flat here. So before I could do that, I have to make sure that this is flat. So I'm going to move over to the surface plate, the stone, and run it on some paper and see how crooked it really is. Here we are at the surface plate stone, and let's find out, just to lay this down here and see. Wow, look at that. This thing, all of these single manifolds all seem to be the same way. So it's got a real warp or a twist or whatever you want to call to it. So I don't know how any of these, I don't even know how they seal actually when it was like that. But at any rate, I'm going to make this flat, and then we'll be able to use this to align the cylinders, and we'll know that it's flat so it doesn't leak. So I'm going to start off with some coarser paper on here and clean it up. So some medium grit emery cloth. So I'm looking for something that's going to take material off in a hurry. I don't think I want to put it in the milling machine, but if it takes too long, I will. So I'm just going to go straight here and see what I got. Yeah, so of course way high in the corners. Wow, I don't know. I think you're going to have to put this in the milling machine and fix it. So now, why do we need to put something across the face on the intake to keep it all straight? Because with the cylinders, as you can see, they can move around wherever they want to go. And if it's tightened, the cylinder head's tightened up when it's like this with the tight at the back and loose at the front. This is of course not flat. So we're going to have a gasket leak here for sure. So now that I have such a nice flat manifold to use on here, then this is going to be my straight edge. Now, because I'm missing the gaskets in there, I'm just putting a couple of washers on it for now, just to make up the difference in the spacing. And then I'll snug it up, and then I'll have the cylinders will be nice and they'll be parallel down this way for the exhaust manifold and the intake manifold to go onto. So if I've got them a little set apart. See, the gap at the back is much tighter back here than here, and I'm not going to tighten these with the gun. I'm just going to run them. But and of course there we've got a beautiful, perfectly straight line in between there. Now these I don't really want super tight because the cylinders are still going to move around a little bit while I'm actually installing this. So tightening, torquing one head versus the other. So I'm just going to get them so they're like finger tight. Just got a little teeny ratchet here. It's finger tight. Now they can still move, and you can probably see it up here. They can still move as a pair, forward and backwards. What I generally do is push them forward, push them backwards, and then get them about halfway in the middle, and I'm happy with that. So now's the time we'll put the cylinder heads on and we'll torque this all up. So now is pressure test time. So I have these plates made up with a rubber gasket on it. I'm going to cover up the exhaust ports, and we'll spin it around and we'll do the intake. And then we'll pressure test it before we proceed any further, because if there's an air leak in it somewhere, now's the time that I want to fix it. All right. Now we can take our manifold off here because the cylinder heads are all torqued. And we'll get our extra washers back and separate them out of the engine bolts. That manifold over there out of the way, and we'll move into plugging up the intake. And all right, those guys are. There we go with that. And a couple of spark plugs to fill the hole, and we'll torque these up, and then we're ready to test. So I just finished pumping it up, 5 psi on the gauge. So it's break time. So I'm just going to leave it sit, and I'll see what it's like when I come back. Hopefully it still says 5, because that's what I want. The coffee break was good, even better, because I'm back and it's still at 5 pounds. So I'm very impressed with that. So that's what I wanted. 0 leakage in the crankcase. So as you can see, I have the sheet metal on here, which is actually aluminum in this case. Intake manifold is on, it's torqued, and the exhaust, the gaskets, the inside gaskets are there, and it's just held in place just by these bolts here. Next step is then to put the fan tower on. If the fan tower goes on, you can't get the tin on, so you have to do it now. That completes part number 5 in the 447 assembly series. Part 6 is in detail of how I took that warped intake manifold and made it nice and flat so that it will seal properly. Part 7 deals with, and that'll be the final one, part 7, deals with adjusting the ignition timing. It's a single CDI on this one, and actually one of my viewers asked me for a video for that, so that was good timing. So I'll get those ones out shortly. Like, share, subscribe, and thanks for watching. Bye now.